there's just so much, like there are these like behavioral traits. Of course, there is cognitive biases and so on, but specifically with like engineers and designers, what I realized is that it is more of an inverse inference problem, and that's where the work of Judea Pearl and all of that like became very, very important to me, because I was using Bayesian approaches, and and my entire work just started focusing on inverse inference. That is, given that we observe a bunch of decisions, can we infer the latent variables, which we can term it as cognitive variables, which are really like these beliefs that people have over an entire state space of actions, or that they can take. What can we tell meaningfully about them by just looking at their data and then adding some theory with it?
Oh,
Um,
so let me see if I understood that correctly, because I think there's something really interesting there when it comes to what you're talking about. It's basically you're just looking at the decisions someone makes and how you can infer and get and gain insight from the decisions, only the decisions, not anything about my personality or the things that I like or don't like. Well, I guess that's part of the decisions a little bit, or all of that plays a factor into it. But you're mainly just looking at the data on the decisions and then trying to gain insights. Is that what I'm understanding?
Yeah, that's right. I can concretize this by giving an example. So, of course, I've conducted controlled experiments and behavioral experiments as a part of my PhD. And since I had a demographic that is mechanical engineering students readily available to, participate in these controlled experiments, one of the settings that we had is that we really wanted to understand, when mechanical engineering students are designing roller coasters, do they have a better understanding of the physics of the problem as compared to if English majors are designing a roller coaster? And so we gave them this sequential decision making problem, because design is an iterative process. We created this experiment where, we gave them this objective of maximizing enjoyment experienced by the riders of this roller coaster. And this is very true to real world, right? Like, you're given this objective, but there's no mathematical quantification to it. So what do we do naturally? We conduct experiments, right? We start ideating on these different roller coasters, and then we start experimenting with them. And experiments can also range from, stress analysis of these coasters, to, roller coasters, to actually asking humans who may be potential riders, do you like the color, or do you like the shape, or whatever it is, right? There's so many ways in which you can gain information. So in my PhD, I kind of abstracted this process on a higher level to create this framework in general of how humans in any field, they're essentially, any human is a designer when they're trying to, achieve an objective. Whether they are satisfying the objective or optimizing the objective, it doesn't matter. But the higher level process is that, you're given an objective, you seek information, you are sampling that space, you learn something from the experiments that you're conducting, you update your state of knowledge, and then you start either refining your experiments or improve the, the space in which you are. And again, do the same process until you finally say that, okay, I'm happy with the solution that I finally have.
And this is quite interesting for me because, this also sort of relates very well with some of the work I've read by Julian Together. He's a game AI
Yep.
professor at NYU. And a lot of people in reinforcement learning are sort of working on these same kind of problems. But I'm going to take the conversation away a little bit from, taking the same foundations where you say, okay, let's understand how people are defining these latent variables to be decisions. You also had one of the papers, which is basically the human-centric perspective on model monitoring, where you said basically the stakeholders desire customization of model monitoring systems. Now, let's say we're talking more so about how do we design data infrastructure systems or any sort of MLOps tools. How does it apply over there, and how much customization is actually required, and what's the process to go about it?
Yeah, that's an awesome transition. So actually, these human-centric preferences, when they are, making decisions, ultimately, the inference problem helps. Like, if you can infer meaningfully something about it, it aids in being able to design systems that are human-centric. And so now if you are designing a model monitoring system, ultimately who is using that system? This is being monitored by humans who are looking at these, dashboards, or they are being alerted on maybe some data drift that's happening, or maybe the system is behaving in a weird way. Now, different people respond to information that is given to them in different ways. So some of these cognitive knobs that are there of how do you present information, is it visually important to them, or is it numerically important to them? All of that ultimately influences the decisions that they will take of like, oh, I do need to retrain my model, or I need more data, or let me inform my bigger team about this model drifting and how much drift is okay for me, right? Like these are all different decisions that people start making based on what they see. So I feel like this idea of preferences it really can be embedded into these monitoring systems, which are really the interface between the human and the AI when you are, you know, trying to create this MLOps framework on top of your ML system.